there's gonna be some certainty in your decision. That would be ideal. And right, the recommendation system is exactly they help us out in this way. They use machine learning to go over all the choices we have and learn what we like and give us the best choice. So sometimes I just found out they really understand me and even better than myself. So as you can see, music platform like Pandora give us recommendation on music, and Amazon gives us some items, and social media like Facebook recommend the people we're gonna date and meet, and some website gives us content, and also the Google searching engine gives us the searching result and we like. So why the recommender system understand us so well? There are basically two ways. The first one is expressive feedbacks. They ask users to give expressive feedback. For example, if you take an online course and then you may ask to give the rating on that one, maybe scaled on 1 to 5 stars. But the problem of it, is that not everyone love to give feedbacks. So the data set is gonna be so sparse. And also everyone's standard of giving rates is different. Like for me, 4 stars is quite good, but for others, if it's not 5, it's not good. And the other way is implicit behavior. The machine learning can help us to understand individuals' taste by implicit behavior. For example, if there's an ad in your laptop, you click it, and then the system may give the similar advertisement back to you. But the problem of this is people always click on something by accident. So it's not always reliable. So how to combine these two together? We have so many methods. There are very basic ones we learned before, like training test split, K-focus validation, and then also top and hit rating. What's that? That is actually we give every like top 5 or top 10, and if the customer or user hit one, choose one, or click one, that will be one hit. So the hit rating will be the amount of hit divided by the total trials. And that's very useful. And there will be more methods will be presented by us.
By talking about the method, I want to introduce two environment we are using. One is the recommender lab package in R environment, and another one is a surprise package in Python. We only implement on the R recommender lab because the Python surprise is actually an enhanced version of recommender lab. And the beauty of that one is you can, that one got a certification from Apache company. So you can use that in Hadoop, Spark, and running a very large data set to do your recommendation. In the R package, so the problem you are dealing with is actually a matrix, which the row vector is the user and the column vector is the item. And then for each cell, for example, for the matrix A, the Aij is going to be the user I, giving their personality to the item J. And the item doesn't have to be like a movie or something. It could be a feature, for example, like the genres of the movie, whether it's a romantic movie or not, or some other features. But generally, we say within the matrix, and you put that in the R system, it's going to convert to the S4 version, which can compute faster. As you can see, the matrix is it's a low rank and a sparse matrix because not all user is gonna give in all kind of ratings or heatings to all items. So there's a lot of non-available value in this matrix, and that is a problem to solving in the recommender system, that you're gonna estimate others' rating to those non-available cell. And here, the real rating matrix means that people really give a rating to the item. And the binary means, like for example, we can set the binary as for movie, if you give more than 3.5 rating, then we set that as 1. And otherwise, no matter it's a low value or it's a non-available, we set as 0. So we only do that that's a binary rating matrix. And here are the very popular, but I personally say it's a low-level method. We can go through that. So something like popular, that's like the top one, we just give the recommendation based on the popularity. For example, on Amazon, actually they're using this way. When you search something, they just give you the product that most people buy and give the highest rating. And random is just pick some randomly method, result to you. For example, on Google search, there's a function called I'm feeling lucky today. And there's a re-recommend, just give you personality, and they're gonna recommend you some stuff you have seen before. But others are relatively more reasonable. For example, this UBCF, that means the user-based collaborative filtering. The collaborative filtering means that they get they compare the similar stuff and calculate the similarity between either items or users. The user base is between users, and there's also an item-based collaborative filtering that's comparing the similarity between items and give the recommendation. The way they're doing the calculation is like the cosine that we have learned in Python class, as a TF, IDF, those kind of stuff. So, and others, for example, there's some shortage for this method. They can only consider one feature, either the user feature or the item feature. So if you want to combine both, there's an ALS method that's called alternative least square. So basically, we know that the matrix is the sparse matrix, so it's low rank. And we can, based on users, get a small matrix, and based on the item, get another small matrix. And we first use the either user or either the item matrix as a variable and estimate one value, and use the estimate value with the other one and do another estimation, and we do iteration like an EM algorithm, sort of. The same way to do that, but definitely different way to calculate that. But it's the same intuitive. And after that, the result will converge to a final value, and that is the alternative least square. And ALS implicit is like you are not doing this calculation based on the real rating, but based on like those click, those computer collected information, not your really personal information to that. And the AR association rule base means, for example, when we talk about onion and beef, you probably will, and bread, you probably will get an idea about like hamburger. So this is association rule based. This means some items, they have some relation. If you have this kind of item, then you probably are describing something else. So that's the reason behind that. And in the Netflix competition, someone, like, I forgot which year, but they got this method called SVD, singular value decomposition. So the singular value decomposition is an improvement of PCA kind of, because if you want to do PCA on the matrix, you probably will only get the principal components on either user base or item base. But singular value decomposition can give you a matrix that have both feature on user and items. So by doing this, you can do the recommendation. And there's a problem with SVD, that is, we know there's a lot of NA value in the matrix. So how to fill out those values to do the decomposition? Should we fill them just with 0? Or should we fill them with the mean of the row or mean of the columns, or whatever value? So the SVDF is invested by Simon's Funk. And the Funk SVD, so he improved it with another loose function, which can judge these sort of things. And it's basically after you're doing the singular value decomposition, and then you do another linear regression, and then you do the calculate the loose function, and then you implement the SVD and again. And after that, you can get the final result. And this way is actually very useful, because after he invested the Funk SVD, in 2009 there is a Korean team invested, made improvement on that based on the mean value. and another team in 2010 on the standard deviation and linear regression estimated value. So let me show some useful functions in the recommender live. So first is a real rating matrix and a binary rating matrix. You can convert any kind of matrix, as long as it's a matrix, to the S4 version. And the normalization, the reason we need to do the normalization is because the way that the algorithm calculates the loss function is doing the gradient descending. And if you don't do the normalization, the computation time will be slow because it's hard to converge. But if you do the normalization, it will be faster. And talking about the similarity we mentioned before, there's not only one way, the cosine, there's also other ways. In this package, it provides actually 10 ways. Other than cosine will be Pearson, J-curve distance, Euclidean distance, bias, affinity, and a lot of what I don't know actually. But you can choose whatever you want. Actually, based on the different type of data you are analyzing, based on the different purpose you want to achieve, the method you select should be different. And this package, what I really like is provide an evaluation schema to help you to do the evaluation. You don't have to write down the fit function and then predict it and then write the confusion matrix and then write down the plot. With this evaluation schema, you can do everything in once. And the method is to provide to do the evaluation are three. One is the split, the simple split. You just provide the training ratio you want to have, and it will run that and give you the estimation. And another one is cross-validation and bootstrap. The K here means how many times you want to run the evaluation. If you set to 5, it will run 5 times. And this schema will choose the best one as the final result. And the given means like if you want to do the recommendation to some person, you cannot give a blank person. You have to give some default value. So with the test data set, this split, in the test split, it will keep the number of given values as base value to do the estimation and to estimate the rest. And the beauty of this one is you can not only select a positive number, which means, for example, if a user rating 20 movies, and if you choose given 5, that means you are gonna use 5 movies rating to estimate the other 15s. You can also choose the negative. If you choose -5, that's gonna leave only 5 non-estimated value for you to estimate. So this gives us a lot of flexibility to do the evaluation. For the prediction type, there are 3 kind of prediction. One is the top n least, which means we'll give you the top n that the algorithm think you like. And one is the rating, which will give you the real rating. The last one is a rate matrix will give the ratings will just give a list of rating, but the rating matrix will give all user and all movies rating matrix. And this system can even do the hybrid recommender, which means you can combine all kind of recommender algorithm together and give them weight and get a final result. So there's a lot of flexibility in this package. So let's see some results. This is a data set from Movie Lens, which is a university collected data set. And the data set we use is not too large. It's only 100,000 observations. Once you spread it as a matrix, it has 996 users and 1664 movies. We try to use a larger data set which has 28 million observations, about 60,000 movies, and a lot of users. However, once we expand that data set to a matrix, that's going to take about 113 gigabytes space. So before I can apply that in Hadoop or Spark, I cannot do that on my personal machine. So we choose the small one. And here you see on the right-hand side is based on the real rating matrix, and on the left-hand side is binary rating matrix. And we can see that the ALS implicit is almost the best one in both. And you can see here the user-based collaborative filtering is much better than here. The reason is because we do some data cleaning in the binary ratings. For those user who doesn't rate more than 20 movies, and for those movies doesn't get more than 15 ratings, we just take them out. Only keep the one, so which makes the matrix more condensed, and we can see in this case the user base improved much, and also the item base collaborative filtering here is almost as bad as the re-recommender and even worse than random select. But here it can be as good as the popular item. However, we also need to note that the calculation time. The calculation time for the ALS implicit takes, for this data set takes 1 minute to do the calculation, but for the popularity, it's only take less than half seconds. And here is, it's very similar, it's just use the cross-validation data set, and it's a bootstrap. So finally, here is a simple output, and you can see on the left-hand side is ALS implicit, and on the right-hand is popular based on the real rating. And since the ALS will do the normalization, so the output is not on the scale from 1 to 5, but it's on the scale from -1 to 1. And you can see there are actually a lot of difference on the predictions. And here is the list of the top 1 list. In the popular one, we can see Titanic, those Cinder's list, those well-known movies. But here, to be honest, none of those. Only Mission Impossible I know, and William Shakespeare's Romeo and Juliet. But that's all. Others I really don't know what kind of movies are they. And this is another result. So all in all, we think like if you don't consider the accuracy, if you really combine the both accuracy and the calculation time, actually popularity is much easier to do the calculation and do the recommendation, and it's very well used in both Google and Amazon. Of course, for Amazon, they are doing the recommender system based on millions or even trillions of products. So they first do the clustering to narrow down the item and the users to do the recommender. But still, the core are still using the collaborative filtering and popularity. So what if you are really facing the problem that you cannot do such kind of estimation because this requires specify the data set? Then that's gonna my colleague to introduce that.
Actually, another, if you're interested in the visualization, you can search data visualization template. It is actually written in JavaScript, I remember.
D3 JavaScript.
Yes, in JavaScript, and you can find it on GitHub. Yes, later I would like to talk about the click-through rate algorithm. It is actually about advertising. Advertising has been a blooming area, and actually generated lots of billionaires. And actually, so one thing that is very interesting here is that the Taobao company, they recommended an instant food as what can keep you healthy on the right hand side, which is a serious blunder. Of course, sometimes they are good, and since advertising can help you to remind you about what you want to buy, or sometimes remind you about what you don't even remember to buy. And here, and since the Taobao has a good and blooming career, one of the papers published by their employees claims that the old algorithms have different kinds of disadvantages. Of course, the LR is logistic regression method and kernel method and FM method and tree method. Sometimes they are difficult to implement with, sometimes they are overfitting, sometimes you need to produce manufactured features which might be costly. So yes, some people working for the Alibaba company, they claimed that there is a new algorithm which can both be fast, accurate, and good. And here we are going to talk about it. And on the left hand, actually it is called the MLR, multi-logistic regression model. It is actually a combination of softmax and logistic regression. On the right-hand side are the basic functions, and on the my right-hand side, and my left-hand side is the AUC function. So actually, although the overfitting problem seems quite a lot if you just look about the height of those of these plots, but actually from the value it is quite good. From the scale, they are almost the same. So and they claim that they can split the data set into the scale it was supposed to be, and once it function, and he also introduced a grid function which is called common feature function, which there are many features about the user, and sometimes we just import again, which might be costly in both storage and time. So he claimed that it can be very good for it to save time and storage space. According to his paper, this simple trick has saved him about 60% of saving space and about 90% of the calculation time. But according to our experiment, it is not that powerful, just about 30%, I think. Some of the talking about the tricks also claim we can use a paramount calculation trick, and actually he used the loss function plus the L1 regularization and L2 regularization, which caused